Hello, everyone. So, in this lecture, we are going to start talking about design patterns, which is like one half of this course, the catalog of design patterns. We're going to start with this introduction right here about design patterns. So, what are design patterns? Well, the second half of this word right here, you can obviously see is the word patterns. And this word is mostly associated with art, with music, for example, how something that is a pattern is something that repeats, for example. In art, a pattern is something like this, for example. And in music, something that has melody that repeats is some kind of rhythm, which is a form of pattern as well. And in this example right here, this is captured in, I think, the side of a building, and the way the windows appear like this, and the way it is framed looks like it's some kind of three-dimensional pattern. So, what are patterns in the context of object-oriented programming? So, design patterns are general reusable solutions to a commonly occurring problem within a given context in software design. So, unlike algorithms, though, which also solve problems as well, design patterns are not clear instructions that can automatically be transferred to your system. Design patterns are more like templates that describe the general concept to solve the problem. They don't really contain this is the pseudocode to solve the specific problem. This is the specific mathematical function that you need to follow to solve this specific problem. It doesn't contain implementation details in the same way that something that is abstract in object oriented programming doesn't contain implementation details. It otherwise contains structural blueprints instead. And the way design patterns are usually presented is through the use of class diagrams in UML. And you'll see me do that as well. So hopefully, when you're watching this video, you've already watched not that, UML class diagrams. You've already read that. So design patterns are not novel and sophisticated discoveries. They are instead typical solutions to common problems. The pattern of these solutions became so ubiquitous that it becomes worthwhile to put a name to it. And design patterns are, in the context of software engineering, are just borrowed concepts actually from architecture and design. And uh, design patterns are actually not discovered things. And I think if given enough time, you as object-oriented programmers yourselves could naturally think of or naturally form these design patterns as you solve common problems in object-oriented architecture. You yourselves will form the same ideas. It may not have the same names as the design patterns that are discussed right here, but you would uh, formulate something similar to the design patterns that we will discuss. So the concept of design patterns in the general context, not just in computer science, is often attributed to Christopher Alexander, an architect, from this book right here, A Pattern Language, Towns, Buildings, Constructions. So these are patterns in building architectural structures. Like, for example, patterns may describe how high windows should be, given that this is the use that this is the context, this is where you're putting the windows, how many levels a building should have, how large green areas are in neighborhoods, and so on and so forth. So, for software engineers, Erich Gamma, John Vlissides, I'm not sure if I'm pronouncing that correctly, Ralph Johnson, Richard Helm. These four used this as an inspiration to publish this famous book right here called Design Patterns, Elements of Reusable Object-Oriented Design. So these four right here became collectively known as the Gang of Four because there are four people that contributed to this book right here. And their book became known as the GOF book, which stands for the Gang of Four Books. The Gang of Four book. It contains a catalog of 23 design patterns solving various problems of OOP design. We're not really going to talk about all 23. We're going to talk about a selected amount here, just a subset of these 23. You can find these 23 in the syllabus, in the course guide, what these are. So, before we talk about patterns, what these patterns are, let's ask this question first. Why patterns? Why are we solving these common problems using these patterns? So, the answer to this problem is similar to the answer when you're asked why you don't reinvent the wheel, for example. And I'm not sure if you've encountered this phrase right here. It's commonly used in programming, reinvent the wheel, where if there exists a solution that is tried and tested for a specific problem, the most practical solution for that is something that already exists, a solution that already is packaged in some library, for example. Like, for example, if you're coding in C, the best way to concatenate two strings, for example, is to use the concat function in C's string library. I mean, for sure, you can implement your own concatenate function yourselves, but would you really need to redo or rewrite the same solution? You're just reinventing the wheel. In the same way, where you don't have to reinvent the wheel uh, to invent a car or to place it in a car, for example, because the wheel is a perfectly good solution to how cars roll. So the same answer to this question right here, that is the answer to why we do patterns. So design patterns are tried and tested solutions. Knowing these patterns will give programmers a toolset to solve a variety of problems in software design. So knowing these design patterns, you don't really have to memorize them, but being familiar with design patterns gives you some sort of uh, a compendium of templates and architectural designs in OOP, for example, that will tell you, this specific problem, I've seen this before. I know the best way to solve this. The best way to solve this is to use this specific design pattern. So, design patterns as well, another important use of design patterns is that how it helps with communication within a team. So a team of software engineers well versed in design patterns wouldn't need to explain to each other what exactly must be done to use an adapter pattern, for example. So instead of describing that, oh, for this specific problem, this object right here must interact with this specific service in this specific interface. Therefore, we need to create this other instance which realizes the interface that we want but contains the specific service that it actually is. All of those words and all of that explanation that you give can be summarized by saying, oh, for this problem, we use an adapter pattern. So it makes communication easier. You'll be able to convey what you actually mean using these design patterns right here. And uh, you'll notice that in large companies where they heavily use object-oriented architecture, for example, most of their lingo would be this design patterns right here. Oh, for this specific part, use this, use this. Oh, this pattern is not working, maybe use this, etc., etc. How about the contrary, the other half of the coin, or the other side of the coin, asking why not patterns? Is there a reason to not use patterns? Of course. So design patterns are sometimes just used to simulate features that the programming language doesn't have. If you have a programming language that isn't powerful enough to solve this specific problem, so you have to use a design pattern. But if you use a powerful enough programming language, you wouldn't need the pattern at all. An example of this is how the strategy pattern right here can be replaced by lambdas if you're solving the problem using Python, using C sharp or C++, for example. So you wouldn't need the strategy pattern because the strategy pattern is just a simulation or a an implementation of lambdas. A little bit uglier lang actually. So also, patterns are not end all be all solutions to any design problem out there. Because at the end of the day, context matters the most. So, an experienced programmer will implement a problem to the dot instead of adapting the pattern for the context. So, this is not really a detriment to patterns in general, but this is sort of the this is sort of what will happen to an inexperienced programmer if the only tool set that he has are these design patterns. For example, you will sometimes tend to force a specific pattern into an incompatible problem, when in fact the most important part of adapting a pattern is adapting the pattern for the context. And actually, this is the challenging part about design patterns, because remembering what a design pattern is, familiarizing what a design pattern is, you can easily do that. You can look up a guide, you can look up a class diagram for a specific pattern, and you can automatically say, so this is how you build this pattern. The challenging part is adapting that for your system, adapting that for a specific context. That is the challenging part. How do you uh, build this pattern into your system? So, where does this specific class appear in your system? For example, which of these classes in your system will correspond to the factory class, which corresponds to the command class in a command pattern? So, those are the challenging questions that you need to ask when you're adapting patterns. In fact, that is the point of the lab exercises that I will giving you. So the lab exercises are focused on adapting a pattern for the context. So there already exists some code written for you, written by me, and the lab exercise will mostly be to adapt a pattern to that particular code, to that particular system that was already written. Because uh, most of the responsibilities that you do as an object-oriented programmer would be to refactor existing code, to be able to adapt these patterns into something that already exists and improve it using that pattern. So sometimes you don't even need a pattern at all. A simple problem can be solved using a simple problem solved using a complicated solution is inelegant. And again, this is not really a direct detriment to patterns. It's just the perils of being too attached to patterns. Because sometimes, if the problem is simple enough, you don't even need to adapt it into some pattern. You'll just be forcing it if you do. Because the simplest way to solve that problem is, of course, the most elegant solution for it. So, there are three types of pattern that we are going to discuss. They're divided into three. You have the creational patterns, which provide object creation mechanisms that increase flexibility and reuse of existing code. So, create. Structural patterns, they explain how to assemble objects and classes into larger systems, into larger structures, while keeping the structures flexible and efficient. This is more related on the architectural part, the structural part, the classes and the objects that form together into a specific mechanism, into a specific uh, construct in your system. Finally, behavioral patterns. So, behavioral patterns take care of effective communication and the assignment of responsibilities between objects. So, behavioral patterns divide the responsibilities between this class and this class, for example, in the way where there's only a single responsibility between them, and it does it in such a way that the the behaviors and responsibilities of a class is as much as possible very decoupled from the other parts of your system. So here's an example of a design pattern right here. This is the first design pattern that we're going to discuss. This is the factory method pattern. And as you can see right here, patterns are usually shown to you or usually discussed to you using class diagrams. And that is all. So we're going to move on talking about, we're going to start with creational patterns, starting with factory method pattern and the abstract factory pattern. For each pattern that we are going to discuss, there is a corresponding lab exercise for that. And when you start with these patterns right here, it might be hard since you might find it hard adapting a pattern to a specific context since again you're still starting, you're still new object-oriented programmers, you're not really that experienced yet. And the point here is to try and to play around with the code that I'm giving you, to play around with the patterns that I'll be showing you, and yeah, you'll be able to do the lab exercises as well. And that is all. That is finally all. Thank you, everyone.